Here's our first problem. I'm going to mute myself and I want you to try this on your own. All right, so the first question, again, 1 minute on that one, and what I want to make sure we understand, because we cannot afford to miss these types of questions on the TEAS test, especially with those more challenging word problems. So there's three things, FDP, let's think fractions, let's think decimals, and then let's think percent. FDP, fractions, decimals, and percents. Now, what we have given to us right here is a fraction that's 21 over 12. What makes this a fraction? Well, we have the fraction bar and we don't have a percent symbol. It's definitely not a percent. You'll have a percent when you see the percent symbol. And I'm going to try to fool y'all right here in a minute on another question. Now, we can always take the top number divided by the bottom number to convert a fraction to a decimal. So 21 divided by 12 gives us 1.75. However, this is only the decimal. This is only the decimal. This is not a percent yet. So when you have your decimal, there's two options here. You can either multiply by 100 to convert a decimal to a percent, or if y'all have seen my video, I use the term D2P, decimal to percent. If you look up some of my percent videos, you will hear me talk about that. But either way, you can either move your decimal 2 places to the right or multiply the decimal by 100, and we do get a percent that is 175%. So therefore, C is going to be our correct answer. And I want y'all to bear this in mind. When you're given a percent symbol in the problem, I don't care what that number looks like. It might have a decimal in it. It might have a fraction in it. But if you see a percent symbol beside some type of number, that number is a percent. Let me repeat that because I'm about to get y'all. If you see a percent symbol beside any type of number, whether it be a decimal, whether it be a whole number, whether it be a mixed number or a fraction, if you see a percent beside it, it is a percent. If that doesn't make sense, let's have a look at number 2. Give it a shot. Very common misconception here. So notice what we have here. We do have a mixed number, but we have that percent symbol. That makes this number a percent. You got to be careful here. Now, very true. If we had just 8 3/5, and say we wanted to convert this mixed number to an improper fraction, then sure, you can take the 5 times the 8 plus the 3, and this will give you 43 over 5. But that's not what we're doing in this problem. This 8 3/5 is a percent. Now, we can take this 8 3/5, that's going to be 8 point something. I'm just going to take this fraction, 3 divided by 5, that's 0.6. 8 3/5% is 8.6. But folks, this is still a percent. Now, this right here, we have all these answer choices. These are fractions. So let's go back to FDP. FDP, fraction, decimal, percent. All I have done is I've taken 8 3/5, I converted it to 8.6. But this is 8.6%. Now, let's take this percent and let's go back to a decimal. Now you might say, how do we do that? Well, instead of us multiplying by 100, we divide by 100. So if you take your percent and you divide by 100, or move your decimal 2 places to the left, you will get 0.086. Take note, if I take that 8.6%, we divide it by 100. This is our decimal. Now, remember earlier we had a fraction, all right? Let's look at our fractions. Let's go ahead and look at choice C. C is going to be our correct answer here, folks. I know a lot of us want to pick A, but let's take that fraction, 43 over 500. To convert a fraction to a decimal, divide the top by the bottom. 43 divided by 500. Notice this decimal we get here. 43 divided by 500 gives you that decimal 0.086. And now if we just double check one more time, to convert your decimal to a percent, you either multiply by 100 or move your decimal 2 places to the right. I know I saw a lot of A's up here. A is not correct because this 8 3/5 is a percent. That changes the whole ball game. That can be confusing, but if you see a percent symbol, it makes it a percent. And let me ask y'all this question. 8.6%. 8.6%. Suppose you took a test and your grade was a 8.6%. That means you didn't do too well, assuming we're talking about out of 100%. 8.6 is not a good test grade out of 100%. Well, suppose you took a test that had 500 questions on it. 500 questions. And if you only got 43 out of 500 correct, that's not that many right. 43 is not a lot of right questions or a lot of correct questions out of 500 questions. So 43 out of 500, there is that decimal. And then if you convert that decimal to a percent, that's how we get that 8.6% back. Now, let's move on. We have another fraction decimal percent kind of tied into a word problem here. A quality control inspector noticed that 1 out of every 400 light bulbs produced at a warehouse are defective. 1 out of every 400. Now read this question carefully. What percentage of the light bulbs produced are not defective? Not defective. You got to be careful with that word. Tricky. So 1 out of 400 are defective. So this is our fraction, F. Let's convert our fraction to a decimal, and we can always divide. So let's take 1 divided by 400. Here's our decimal. We get 0.0025. Let's convert our decimal to a percent. We can either multiply by 100 or move the decimal 2 places to the right. This gives us a percentage of 0.25, and this is 0.25%. All 3 of these things mean the same daggone thing. This fraction is the same as this decimal, and it's the same as this percent. Now, this is the kicker though. So this is the percentage of the light bulbs. Percentage of the light bulbs that are defective. However, we are trying to find, put this in the notes, and by the way, all of these notes are going to get shared in the group. We are trying to find the percentage that are not defective. So that tricky word there. Now you might say, okay, how can we do that? Well, if we know 0.25% are defective, take 100% and subtract that 0.25%. And this will give you that 99.75%. That's the percentage that is not defective. Yes, you can use a proportion here. I'm trying to really, stick in this FDP, converting between fractions, decimals, and percents. But D is correct. And let me show you another approach before we jump into the next problem. So, if 1 out of 400 are defective, then the remaining 399 are not defective. 1 out of 400 are jacked up. The other 399 are not jacked up. So let's write that as a fraction. 399 out of 400. Let's divide that to get a decimal. And look what happens. 0.9975. So this is our decimal. 0.9975. And that percent is 99.75%. So notice the percent symbol. That percent symbol is that's what makes it a percent, by you putting a percent symbol on the end of it. So now we didn't have to subtract this from 100 because technically I did my subtraction right here. I took away the 1 light bulb that is messed up, which leaves us with those remaining 399 that are not messed up. I hope that makes sense there. Multiple approaches, absolutely. But that's how I would approach that problem, especially tying in fractions, decimals, and percents. All right, so we're good here with number 3. Now we're going to start doing some is over of. I'm going to go ahead and write the formula down for you because this is anytime you run across a problem like this where you have like the words is, you have the word of, you're trying to find a percent or you're given a percent, you can use this formula. Is over of equals percent over 100. All right, so there is a faster way of doing some of these problems, but some of us get mixed up of when can we multiply by a percent, when can we divide by a percent, all that stuff. That's what this formula is for, to take away that confusion of when should you be multiplying by a percent versus when should you be dividing by a percent. So if we have a question, and we're going to do 2 more of these too to get some practice in. The question says, what is 85% of 32? We can plug these numbers in. Of 32, I'm going to put that at the bottom spot. We are given a percentage of 85, so I'm going to put 85 over 100. And then the question says, what is? That is what we're trying to find. The word what is where we can put our variable. So watch this proportion I'm going to create here. We're trying to figure out the is part. What is? I'm going to put X over the of 32 equals our percentage, 85. And when you use this formula, you don't convert it to a decimal. You don't put the percent symbol down. You just put 85 over 100 because, folks, 85 over 100 is 85%. Now let's look at quickly, how can we solve proportions? We will be doing several proportions tonight. If you look at all 3 of your numbers here, this is a huge time saver. In this particular problem, the 100 is going to be getting cross multiplied by X. Whatever number is getting cross multiplied by the variable will be the number that we always divide by. So let's not worry about the 100 right now. Let's cross multiply the other 2 numbers first. 32 times 85. I don't care what that number is. Don't waste your time and write it down. Immediately divide by this 100 in this case, because that's the one that's getting multiplied by X. So if we divide by 100 here, we get 27.2. Therefore, A is our correct answer. And let me show you that shortcut one more time. Immediately multiply the 2 numbers that don't have an X first, 32 times 85, and then immediately divide by the number that's with the X. Divide by 100. Now, it might not always be 100, and I want y'all to pay attention to that. Don't always think that you're going to be dividing by 100 in these problems. That's not what I'm trying to tell you here. In this case, we did. 27.2 is our answer. Now, let's look at a similar problem. Is over of equals percent over 100. Give it a shot. All right, so number 5 is we have that same type of question. It's got that same feel to it, though it's not the exact same question, but yet we can use this formula yet again. Notice what we're going to be doing here is we're going to be finding a different, I don't know what happened there. Let me go back and try copying this again. There we go. So same formula, but we're going to be finding a different piece here. So if we look at the question, it says what percent? We don't know what percent. We're going to put our X right here in this spot. Of 64, that is our of piece. That's going to go at the bottom, is 80. Finding a different piece, but the same formula will work. So is 80, that goes up top. Of 64, that goes at the bottom. And then we're trying to find a percent, so we're going to put that X over 100. Cross multiply and divide. And let's do that quick way again. Just bear in mind, the 100 is not what we're going to divide by here. We're actually going to divide by 64. See the difference? So let's take 80 times 100 first. I don't care. 8,000. Don't write it down. Don't waste your time. Immediately divide by 64 in this case, because that's the number that was getting multiplied by X. Now, the thing is with this problem, when you get that 125, this represents a percent. So it's already in percent form. So our answer is going to be 125%. That is something that commonly confuses students with these is over of problems. the percentage, we're putting it over 100. So 125 over 100 is 125%. Anything over 100 is a percent. But yeah, D is our correct answer there. And we should have, I mean, if you think about it, you're talking about what percent of 64 is 80? 80 is more than 64. So it has to be more than 100%. And this is the only answer up here that makes sense. So there's another is over of. We got one more. Maybe you're seeing a pattern here. Back here, we found the is. This problem, we found the percent. Take a wild guess at what we're going to be doing here. All right, number 6, yes, it can be worded a little bit differently. It might not be those exact words. It says find a number such that 75% of that number is 228 over 5. All right, so I really want to hit home with the fractions, decimals, percents. 228 divided by 5. Let's go ahead and divide that to see if we get a nice looking decimal. That is 45.6. This is a fraction, but I'm going to use this decimal instead. And let me see if I still have my formula. Yes, I do. So let's see what we got here. We want to find a number such that 75%, that's our green piece, of that number, we don't know the of piece. Of what? Of that number, we don't know. And then the is going to be this 45.6. So let's plug and chug. 45.6. That's much nicer to use than that fraction when we're solving this proportion. We don't know the of spot, and we do 75 out of 100. But now that we have this, cross multiply and divide, the 75 is what you're going to divide by this time. So 45.6 times 100. I don't care what that gives me. Immediately divide by 75, and we get 60.8. So D is going to be our correct answer. So what we've done in those 3 examples is we've covered every single possible thing that you could find in the is over of equals percent over 100. Now, speaking of, more practice of these and tons of other stuff, really, the bulk of tonight's session does deal with section 10 in my workbook. It does deal with section 1 as well, fractions, decimals, and percents. But if I go to section 10, that's some of the first stuff that's in section 10. Is over of, percent over 100. But obviously that section 10, in my opinion, is probably the most important section in the entire workbook. But that's some more practice there. And now let's switch gears. The next topic here. So what I have here, I was digging when I was creating this lesson. I was like, all right, let me show them a real life example. So the day before Halloween, I took my MacBook Pro. I have a 2018 MacBook Pro. I just purchased the brand new ones. If y'all are familiar with Apple, they just released like this new M1 Pro and M1 Max. So I'm waiting on that to get here. I went ahead and replaced the battery at this place in Greenville, North Carolina. I live in North Carolina, and you can literally walk in that store with a cracked phone screen or a battery replacement, drop it off, come back 4 hours later, and it's good to go. So I put a new battery in my MacBook Pro, and what I want y'all to see down here is what you might see on a receipt. So if this is blurry, I'm going to focus my attention on this part right here. So we have the subtotal, and that was $160. We have the sales tax, and sometimes your receipts will even show what the sales tax is. In this case, the sales tax is 7%, and it looks like that's $11.20, and then we have our total. So this is what I ended up paying. It was $171.20. Now, the reason why I'm showing you this is because this is like a real world application, and I want to show you ways that we can think about how to compute sales tax if we don't know it, or if we do know it, or whatever. Now, the quick way, and I would recommend knowing this, instead of doing a proportion, yes, you can do a proportion, but the quick way, if you know what the subtotal is, that's like the price before tax is applied. All we really have to do here is take the price before tax plus the sales tax, and this will be equal to the total that you pay. And this applies to groceries, anything where you pay sales tax. Watch, I'm kind of building a formula here, but this formula is going to be easier to work out than say the one we're going to do right here in a few minutes. So price before tax, that's the $160. Now, where does this $11.20 really come from? Is sales tax is 7% of whatever the subtotal is. So what we're going to do is we're going to take 7%. I'm going to use my decimal conversion for that. Notice if I take 7 divided by 100, 7 divided by 100 is 7%. There is your decimal. So if we take 7% of times the subtotal, this is how you figure out sales tax, folks. So let's do that. Let's take the 160 plus, let's take 7%, 0.07, times your subtotal. We get 11.2. That is not $11.02. That is $11.20. So you can see where these numbers are really coming from on this sales receipt. And then obviously if we add these two things together, that's where the 170, 120 comes from. So I'm not trying to waste your time here. I'm trying to show you, like, this is how sales tax is computed. If you know the price before tax, the subtotal in this case, and you know your sales tax rate, 7%, you multiply that percentage by that price before tax to find the tax that you got to pay on that item or that purchase. This same exact approach applies to leaving tips when you go out to eat. This is coming. When you find sales tax on a dinner, if you go out to eat for dinner, you have a subtotal. Then they have a tax applied, whatever tax that may be. And then sometimes you might want to leave a tip. So that's going to build up this next problem. And this one does require a little bit more thinking. And I'm not going to use proportions here. I'm going to use, taking this approach. And I'm telling you, sales tax and tips work the same way. You're finding percentages. So here is our next question. All right, so this is, we're going to do another one similar to this in a moment, and it's going to be a little bit trickier. So let's break this down. Again, I'm not going to use proportions. I'm going to use the way I would do it, and I want you to know how to do it this way. I want you to know as a person how to find a quick way to find a tip when you go out to eat, instead of just throwing down money on the table. If you really want to find a 20% tip or whatever, and how do you find sales tax? So let's break this up into three things. This $88.24, that's the cost of the meal before the tip and the tax. So let's think of that as the subtotal. That's just the price of the food. So that's going to be $88.24. Now we have two things we're doing here. We're going to do some sales tax, and in this case that was a 6.75% sales tax. So what we're going to compute here is we're going to say 6.75%. Move your decimal 2 places to the left or divide that percentage by 100. Same thing either way. So we're going to do 0.0675 and we multiply it by this subtotal, just the cost of the food. While we're here, let's go ahead and do that. So we have 0.0675, multiply that by $88.24. Now here you have to round. Now when you have these funky decimals like this, you want to round that to the nearest cent. So this would be $5.96. That's how sales tax is calculated. If the decimal's long, the nearest penny, the nearest cent is what you round to. So this 6 to the right of this 5 tells that 5 to go up. We got the sales tax of $5.96. Now let's come and leave the 20% tip. Must have been a good waiter or waitress. We take 20%. You can just do 0.2 or 0.20. Check this out, y'all. If I take 20 and I divide it by 100, that's 20%. We get 0.2. Some people like to say 0 like this, 0.20. There's nothing wrong with doing that. It's just that this 0 here to the right is called a trailing 0 and you don't really need it. Notice if I just press enter with this on the screen, it just throws away the 0. It's the same thing. So let's take 20% of the cost of the meal again. And this is what happens. I mean, typically the tip and the tax, they're calculated based on the cost of the meal. So the cost of the meal, $88.24. We're using that $88.24 in both of these cases. So let's take 20% of $88.24. And this is going to be $17.65. Again, the 4 goes up because we ran into the nearest penny. So that 4, our 8 tells the 4 to go up to a 5. If you do these calculations separately like I'm doing here, and suppose you get an answer that's not exactly matching what you see, just go with your gut. We do want to add up all 3 of these to find the total cost of the meal, including the tip and tax. We're going to add up all 3 of these things that I'm circling in yellow. And we get $111.85. And I put this up here for a reason. If you do these calculations separate, notice that we are about a penny off for the answer. The true answer, 7B, $11.80 or $111.84. This is where you got to go with your gut. And I did that on purpose. I don't want you to sit there and rework the problem just because we're a penny off. But what I do want y'all to realize, what we've done here, because the next example is going to be a little bit tricky. What we have done here, so we've taken all 3 of these prices and we've added them together. Now, the next problem that's coming up, I'm going to tie some algebra into it. Of course, we can use answers to guess and check. But again, big thing here, if you're a penny off in your calculation, don't sit there and rework the problem. Go with your gut, move on to the next question. And speaking of, here is the trickier one of these 2 dealing with food. All right, here is the tricky one, y'all. Here is the tricky one. So, I'm going to go back to the previous problem, and I'm going to copy over some of this stuff. Some of it I'm going to delete, but nonetheless, I want y'all to see how we're going to build an equation here. So let me slide this over. We got subtotal, we got sales tax, and we have a tip. Now, obviously, some of these numbers need to be erased. And let's see here. So the 20% tip is now a 25% tip. And the sales tax is now 6% sales tax. Now, these are the 3 things. Now, I know it's tempting to pick B. B is not correct, unfortunately. Because this $1,000, that's an expensive meal, by the way. $1,000 on the table at Pepper J's. I guess it's like a spinoff of Salt Bay. I don't know. But $1,000 at this restaurant. And that covered everything. It covered the food, a 25% tip, and the sales tax. This $1,000 represents the total, the grand total. So we want to come back when we add up the subtotal, which is the cost of the food. When we add that plus the sales tax plus the tip, this is going to be $1,000. This $1,000 is not the price of the food. And if you're multiplying 25% times 1,000 and 6% times 1,000, that is not correct. You can only multiply these tips and these sales taxes by the cost of the food. That's the thing we don't know. So we don't know the cost of the food. I'm going to call that X. This is the difference. In the previous problem, we knew the cost of the food before the tip and before the tax. But we're actually trying to find this number. This 88.24, we knew what that was a while ago. We don't know the cost of the food. That's what we're trying to find. Well, how do you find sales tax? We take 6%, 0.06, and we multiply it. Now, look at what we did, y'all. Pay attention to this. A while ago, when we found sales tax, we took the 6.75% and we multiplied it by that cost of the food, by the subtotal. We don't know that in our problem. We called it X. So I'm going to put an X here. And then same thing down here with the tip, y'all. You don't take 25% of the grand total. You take 25% of what the food cost. Let's go back. How did we find this tip a while ago? We took 20% of the cost of the food. So we don't know that. We're going to do 25% of the cost of the food. I hope y'all see how this is different now. We don't know this number up here. And what I'm doing is I'm tying in some algebra because you are going to have some type of equation or equations on the TEAS test. So let's just write this out in an equation that we can clearly see. And most of the time when you have equations, it'll be written out horizontally. So the cost of the meal, let me keep my colors the same. Cost of the meal, X. That's the subtotal. Plus the sales tax. That's 6% of that subtotal. Plus the tip, 25% of this subtotal that we don't know. And then finally, we add all this junk together. That's going to be equal to that $1,000. And again, that's because that $1,000 covered everything. It covered the food, the tip, and the sales tax. So we have an equation that we have to solve here. And this brings in the idea of combining like terms. This is an understood 1 in front of that x. And we're going to combine all three of these. So 1x plus 0.06x plus 0.25x. If you take 1, let me clear my calculator out, 1 plus 0.06 plus the 0.25, you get 1.31. So combining all three of these terms, we get 1.31x, and we set this equal to the $1,000. Now we divide by 1.31. We're trying to get x by itself, so let's divide both sides by 1.31. And this will give you a value for x. Take note of what x is equal to. Let's go ahead and divide this. 1,000 divided by 1.31. And we get this funky number. Obviously, we need to round to the nearest penny. $763.36. Let me copy this crazy decimal over there just so y'all can see that. Obviously, you will never see a check, a subtotal for a meal. Hopefully, we never see a meal that expensive. But there are some restaurants that are charging outrageous prices for tomahawk steaks wrapped in gold leaves, if you know what I'm talking about. But this 763.36, that answer is D. That is our value of x. And what does x represent? The subtotal. You cannot find 25% of 1,000 and 6% of 1,000. That when you're doing that, y'all, look at what we did back here. When y'all get these notes tonight, go back and look at these two problems very carefully. The way you find sales tax and the way you find tip. You multiply those percentages by the cost before the tip, the cost before the tax. It's called the subtotal. It's just the price of the food in general. No tip, no tax. And look, that's what we did here. We multiplied by $88.24 for both of those. But we knew that. We knew the cost of just the food in that previous problem. Here we don't. But we're doing the exact same thing. It's just that we're multiplying by X because we don't know what that value is. And that's exactly what we have solved for down here. For those of y'all that got 690, it's not going to work. Because if you go back, if you say that this is 690, which is not correct, if you go and find 6% of 690, 6% of 690 bucks, that's going to be $41.40. Again, this is not correct. If you go back and find 25% of 690, 25% of 690, we get $172.50. If you add these up, you will not get $1,000. Let's see what we get. 690 plus 4140 plus 172.50. If I did this right, notice that's not $1,000. And this is just like that problem. If y'all search the Facebook group for the word restaurant, and you'll see a problem very similar to this. But in this particular one, if I did my math right, if I typed everything in correctly, that you can see this is not correct. So what we could do is this. Let's take this answer choice and let's just go back and check our work. So this should be the answer, $763.36. If we find the sales tax on this, if we find 6% of this one, 763.36, we get $45.80. We don't round up to 81 here. So $45.80. If we find the tip, we take 25% of this cost. So let's take 25% of that subtotal, 763.36. That's $190.84. That's going to be a happy waiter or waitress. That's their tip. Let's add these together and see what we get. 763.36 plus 45.80 plus 190 84,000 bucks. My point here is this: if you don't like that equation approach, that's the way you do it. But you can, it will take you a while, especially with this being the last answer choice. You can go back and try all of these. Plug these in for the subtotal. Let those be the subtotal. And work it out like we did this problem back here. And the only one that's going to add to give you 1,000 bucks is choice D. But I know we're well past 10 o'clock and we still got several more to do. So I want to proceed forward with the next word problem. All right, so let's kind of, I mean, you know, we all go shopping and probably we might not sit there and whip out our cell phone and find out how much an item's going to be, but I'm going to act like we're going to do that. So a way that you apply discounts, there's two things I want you to know. To find the discount amount, you're going to take the original price and you're going to multiply it by the discount rate. And actually that's the only thing we really need in this problem, but I'm gonna go ahead and throw another formula down here as well. We don't need it for this problem. If you want to find the sale price, what you do is take the original price and you subtract the discount amount. Now I'm putting that formula down here because we will kind of come back and just look at a little bit extra in this problem. Now this question says, how much money will the customer save? So we're not trying to figure out, and I did kind of try to trick you up here, we're not trying to figure out how much money the customer is going to pay. We're trying to figure out how much the customer is going to save. We're trying to figure out the discount amount. How much money are they going to save? So the way we figure that out is we take, and all we have to do here is take the original price, $1,499.99, and you multiply it by the discount rate, which is a 25% discount. Let's do that. $1,499.99, pretty much $1,500, times 25%, 0.25, and we get $374.9975. And it does say round to the nearest dollar. Regardless, this would go up to $375 anyway. But this is the discount amount. This is how much the customer will save. Now, the question could say, hey, what's the sale price? To find the sale price, we take the original price of $14.99.99 and we subtract the discount amount. Now this could be another question you could see. So the original price minus the discount amount, subtract that 375 bucks. This is just another type of question you could see. So let's take the $14.99.99, subtract the discount, the amount of money the customer's going to save, and that would be right around $1,125 approximately. $1,124.99. Of course, we're not talking about sales tax, but I do want y'all to see two different types of questions you could run across here. What's the discount amount versus what will the customer pay? So I did try to trick you there. Notice that that dollar amount does kind of pop up right here at C, $1,125. That's how much the customer would pay. But we were asked, how much money will the customer save? So I think I have a trickier discount problem coming up. Number 10, we're almost done, folks. All right, so we are, what are we given here? Sandra purchased a swimsuit on sale for 42 bucks. The original price was 50 bucks. What was the discount rate? So yes, we can use proportions, but I like to think about this in terms of, you know, without doing proportions. It's really a quick formula here. And I know you're thinking, man, I got to memorize all these formulas on top of geometry stuff, but I'm trying to show you the fast way as well. So let's look at this one right here. Discount amount equals the original price times the discount rate. In this particular problem, the discount amount, what we could do here is we can take 50 bucks minus the $42. There is a difference of $8. That is the discount amount. That's how much the customer is saving. They're saving 8 bucks. Sandra, in this case, equals the original price. The original price was $50. So bring that on down. And we're trying to find the discount rate. So the discount rate, we don't know. I'm going to call that X. And now we have an equation. So divide both sides by 50, and we will have this answer right here. So divide by 50 to get the X by itself. 8 divided by 50, and we get our decimal representation. We get 0.16 is equal to X, which is our discount rate. This is a decimal. Convert the decimal to a percent. 16% discount. If we take 42, the sale price, divide by the original price. So sale price divided by the original price, let's divide that. 42 divided by 50. This 84%, this 0.84, this actually represents the percentage that the customer will pay. So I'm showing you some alternative approaches here. 84% is what the customer will pay. Now, discount rate, you take 100%, subtract the 84%, and you can still get the discount rate this way as well. So there are so many ways you can do these problems. I'm trying to show y'all speed. I don't want people to run out of time. So 2 more problems. We're going to move into graphs. I did a live session. I can't remember which one it is, but I did share that link with you all earlier. There was a live session I did where we covered circle graphs. And if you actually look in the title of the live sessions, I mentioned circle graphs in the title, and I didn't use a particular formula there. I was focusing on speed, but I know people have been saying, hey, let's do some proportions. So I'm gonna back up and we're gonna do some proportions for these, showing you alternative approaches. There, you find what works best for you. If you're getting the right answer and you don't do the same way I did it, roll on with it, no problem. Now, like circle graphs, bar graphs and circle graphs can be used interchangeably. You can use a bar graph to show the same thing that a circle graph will show you, and vice versa. The thing with bar graphs, you have to look at that bar graph very carefully, and you have to understand what these numbers on the bar graph represent. I cannot stress how important it is when you have a bar graph on the TEAS test. Look and see what those numbers represent. These numbers do not represent the number of people. These numbers represent the percentage of people. So this 10 for pineapple is not 10 people, it's 10% of the people. Strawberries, not 30 people, 30%. Pears, 25%. Apples, 35%. Now, for bar graphs and circle graphs, I am going to give you a formula. I am going to tie in some proportions here. Again, just showing alternative approaches. This formula will work for pretty much any bar graph or any circle graph. And heck, if you have bar graphs and circle graphs on the TEAS, it's one formula. It kind of ties back to the is over of equals percent over 100. And it's not going to be is over of. I'm going to give you some different words. And that's going to be the following. Part over whole is equal to the percent out of 100. It's just a variation of words. Is over of equals percent over 100. So part is like a portion. The whole is the whole, the total. And then we have a percent over 100. Now, a total of 180 people. This is our total, aka the whole. So that's going to go at the bottom of this first fraction. Now, the question says, how many people did not choose the most popular fruit? Did not choose the most popular fruit. There's a couple of ways you can determine that. You can either take 100% and subtract the most popular one, which is apples, 35. If you take 100% minus 35%, you get 65%. You can add those 3 together. Let me restate that again. You can take the 10 plus the 30 plus the 25. That's going to give you a total of 65%, which is the same thing as taking 100 minus the 35. That's still going to give you that same 65%. So since this is a percent, because the bar graph says percentage of people, we're going to put that 65 over 100. And the missing piece that we have here is the part. And let's read that question again so we can understand why are we really finding the part. We are trying to find a portion of the total. There's a total of 180 people. We're trying to find the ones that did not choose the most popular fruit. These three fruits only represents a portion of the whole, a part of the whole. We're trying to find those people, that part of the total of 180. So part is a portion, whole is the total, percent over 100. Now we can cross multiply and divide. So 180 times 65, don't care what that is, immediately divide by 100. And what we have here is 117 people did not pick apples. They did not pick the most popular fruit. Now for my speed folks, we could have done this as well. If you know the whole, if you know the total, aka the subtotal, kind of works back with tips and taxes. If we know the total and we know the percentage that we're looking for, you could simply do this. You can take that percentage, that 65% of multiply the whole, 180. We get 117 that way as well. Some of y'all might have done this. Some of y'all might have found 35% of the 180. Let's do that. Let's find 35% of the whole of 180. This represents the people who did pick apples, the most popular fruit, but we want the ones that did not. So we can take 180 and subtract the 63 people that did pick apples. There you go. Same answer yet again. So many ways to do it. Find what works best for you. And what I want y'all to realize here too, this part over whole equals percent over 100. This is a very, very versatile formula. Just like earlier, all of those examples we did with the is over of equals percent over 100. This formula here is very versatile. You can find the part, you can find the whole, you can find the percent. Speaking of, all right, last one. So, bar graphs. Make sure you look and see what these numbers actually represent. In the previous problem, these numbers represented the percentage of people. In this problem, these numbers represent literally the number of people. So pizza lovers at this local dive bar, this is not 35% anymore. This is 35 people. Chicken wings, 25 people. Hamburgers, 20 folks. Hot dogs, 30 folks, and tacos, 15 people. Now, I'm going to go back and steal this formula, bar graphs and circle graphs. If you have trouble with these, practice with this formula. Part over whole equals percent over 100. Now, if we look at the question, it says, what percentage of the people? We're trying to find a percent. So we're going to put that X over 100. We're trying to find that percent spot. Now, part and whole. So part, what are we trying to find? We're trying to find the percentage of people who chose chicken wings or tacos. Chicken wings was 25 people. Tacos was 15 people. Now we add these together. It could be chicken wings or tacos. We add them together. This is a total of 40 people. Now, y'all, these 40 people do not represent the total number of people. These 40 people only represent part of the customers, a portion of the customers. So that 40 is going to go in our part spot. Now, you might say, well, we got to know what the whole is. So to find the whole, add up all of them. The 35 pizza lovers plus the 25 chicken wings, 20 hamburger folks, 30 hot dogs, and 15 tacos. Oh, what do we get here? 50, 60, 80, 110, 125. So 125 represents the whole. This is the total number of customers. That is our whole. And now we're ready to cross multiply and divide. So with proportions, in this case here, we're going to divide by the 125. Let's take the 40 times the 100. Immediately divide that by 125 and we get a percentage of 32%. 32% of the customers chose chicken wings or tacos. And just a way to kind of tie this all together, going right back to square one, the very first problem tonight. Y'all, check this out. Look at this fraction. 40 out of 125 customers either chose chicken wings or tacos. Listen to what I'm saying. 40 out of 125. That is a fraction. 40 divided by 125, I've just converted that fraction to a decimal, 0.32. Now, to convert that decimal to a percent, you multiply by 100 or move your decimal 2 places to the right. It's the same daggone answer. And some of y'all may have spotted that. Y'all may have spotted, hey, we got a fraction. There's so many ways to do these problems. I hope you found something that you can apply that will be helpful for percentage problems that you'll run across on the TEAS. Thank you all so much. I hope you found this helpful. Tune into the group right here in a few minutes. I'm going to add the notes there, and I hope you all have a great weekend. See y'all in the group. Good night.